in smart grid from the DOE is going to be leading that off for us. And then after that, we'll have Muffi Ghadiali, the head of Ford Pro Charging. And then Steve Letendre, PhD, and the Vice President of Policy and Regulatory Affairs for Nuvve Holding Corporation. So I will begin by turning it over to Chris Irwin to get us kicked off today. Chris?
Thank you very much, and welcome to this this discussion. I'm just going to get right into it. I work at DOE in the Office of Electricity, but I'm part of sort of a broad multi-office collaboration within the Department of Energy, operating under the EV Grid Assist banner, is to make sure that we have as concerted an effort as possible to coordinate multiple DOE agendas and mission objectives and make sure that they're well communicated out. Today, what we wanted to focus on is, been to lots of different forums and things like that. And the inevitability of transport electrification is pretty much cemented at this place in terms of the economic movers of some of the largest manufacturers in the world are kicking this off. And the economics of owning and operating an electric vehicle is on the right trajectory to be basically an inevitable consequence of what we do as a society. What that means, of course, is by 2030, we may have close to 30 million electric vehicles on the road out there. And so rather than adapting to each new penetration level of electric vehicles and upgrading this and upgrading that as the minute impacts come to us, it is far more efficient to understand our destination and find the most efficient investments, technologies, and policies that have the optimization over the long term. So that's really our goal here, is to figure out how to plan for that destination. Ultimately, those very high penetration numbers can't exist without everybody coming out ahead. That's the customers, all the manufacturers involved in this, the utilities, and society in general. And so that's really what we're looking here when we look at these examples we have today, is how can each stakeholder in this be happier with the future than they are with the present tense with their internal combustion engines. And of course, there is always a span of approaches from simple to complex, and we in general won't be leaving any of those solutions behind. We'll simply be layering more and more onto that as we go forward. So with that, we can go to the next slide, please. So we borrowed this slide projection from our friends at EPRI, because this is not the conclusion of a 100-page report or something like this, but this is something where some of their researchers took very simple assumptions about the number of electric vehicles that are proposed to be on the road and treat them as the energy system would prefer to treat them, as just batteries. And what we see is that the amount of energy storage represented in vehicles today already outpaces the amount of stationary battery storage on the grid. And as it moves forward in time, the amount of battery storage in electric vehicles will always be greater than can be stationary on the grid. So it's an enormous potential resource. And as you'll hear in these presentations, as customers choose that bi-directional capability for their vehicle, either for a home optimization or a work optimization or an economic one, is that capability is something would be a shame not to tap into for grid economic and operational flexibility as well. What we can see is, even with conservative estimates about number of vehicles that are stationary, number of vehicles that would be bi-directional and things like that, it is one of the best potential distributed energy resources we could have to modulate the impacts on the distribution system, but all the way up to the bulk system. And we think that even with the discounts and adoption and the way things are going, is that it's a resource that we have to confront and understand right now in order to get ahead of it. Next slide, please. So when we're talking about layering on different solutions and things like that, we are, of course, going to start out with the simple ones: a time of use rate, a managed charging operation where there's a little bit of direct involvement of potentially the utility with the charging behavior of the vehicle. But as we know from other demand response programs and things like that, there will be a limited customer base who's willing to engage with those options and to make the best of them. And so what we're looking at is the fact is that more complex and more nuanced engagements between electric vehicles and the grid is the way to obtain higher functionality in the system. And so what we've got here is a notional diagram as that as we have increasing EV penetration levels, if their impact on the grid is to be modulated, it will need to be done through progressively more complex options, going from the simple actions that we have today to the managed charging of V1G, of one directional load management. But the appetite for control in the grid as we go bi-directional, as we go for distributed energy and decarbonization, we will have more appetite for control, and EVs with V2G capability are going to be increasingly the best economic source for controls outside of the utility's own asset base that it operates out here. The most important thing for me is that customer-owned EVs will not work for free. And so customers need the right incentive, and that incentive cannot be out of scale with what utilities pay for control services today from the ones that they own, maintain, and operate. So it has to be a competitive resource for the utility in addition to being a preferable option for a customer themselves. Next slide, please. Finally, a lot of our discussions when we talk about vehicle to grid functionality tends to obsess over the load dimensions of just the energy scheduling capabilities or reserving for services in the future. But the way DOE and others parse it, there are at least a half dozen fundamental grid services that are possible with any distributed energy resource. And so as we think about maybe an ancillary service market or things like that, which are fairly complex, people worry that these are sparse markets, that the presence of DER will drain all the value out of these markets. But we're quite confident that the appetite for control services across the grid services spectrum will only go up in the dynamic system that we have to operate to run the system that we want today. I believe with that, we can go to the next slide. So this is our headquarters email. And now I'd like to introduce you to Muffi Ghadiali of Ford Pro.
Thank you so much, Chris, and my pleasure and honor to be here to present today. By way of background, we are part of Ford Pro, which is a dedicated business unit within Ford Motor Company that's focused on the commercial customers, commercial meaning fleets, private fleets that operate vehicles for business. It also includes government fleets, which is one of Ford's largest business segments. Ford Pro Charging is a dedicated business unit within Ford Pro, and my team owns all of the responsibility for hardware, software, as well as services that we offer to our charging customers. And I'll, for the purpose of the presentation today, I'll speak a little bit about general perspectives on why charging is so important to electrification in general. I'll share a few of our customer perspectives. And also some of the things that we need, not just at Ford Pro, but also as an industry. So with that, next slide. And so just to build off of what Chris said, electrification is now going mainstream. So it's no longer a luxury. And to give you very specific examples, you already heard of the F-150 Lightning. That's an iconic American vehicle, the best-selling truck for more than 40 years, now being electrified. Same is true with our e-Transit, which is one of the most popular vans commercial vans in the market, not just in the US, but worldwide. And as these vehicles start to electrify, it brings interesting opportunities and challenges as we bring real world vehicles to scale. Next slide. And this is where things really start to get interesting for us as a business. And one of the reasons why we as Ford are investing in charging is if you step back and look at EVs, or in fact, just transportation in general, if you look at mobility and fueling, they've always gone hand in hand. And this has been true for the last 100 years since the advent of the first Model T. There is a fueling network that is built around vehicles in general. So if you think about gas stations today, there's a reason why a gas station is placed where it is. And there's a reason why the gas tank in our vehicles are the sizes they are, because they've been designed around a fueling network that had evolved over almost the last 100 years. As we move towards electrification, all of that is being disrupted. So not only do EVs bring opportunities, but there are some really interesting challenges because of the fueling network that has to be rebuilt from the ground up. And this fueling network, as we all know, is very different. Instead of moving oil over containers, now we are moving electrons over the grid. And it's creating some really interesting challenges for our customers as they are beginning to scale up. If you can go to the next slide. And so, just to build on what Chris was mentioning, this is a complex undertaking in many different ways. So when we talk to our customers, primarily fleet managers, they love the EVs, they love our products, which is why we are, selling everything that we can build right now. But the thing that they are more concerned about right now is how do we actually get the charging infrastructure in place? And from their perspective, it's a significant change because now suddenly you have to deal with your local utility, you have to deal with infrastructure changes, construction, electrical, as well as hardscaping, installing the chargers, connecting those chargers to the cloud so that they can be managed, and then tying all of that to the vehicle delivery. And all of these things represent a very complex undertaking for customers who are just beginning their transition. Next slide, please. And these are a few perspectives from our customers. Like I said, they see the benefits in electric vehicles. So they see the lower cost of operations. Electric vehicles have less moving parts, lower maintenance costs, no oil changes. That means they're on the road, so they can see the benefits in terms of the total cost of ownership. But what they are now concerned about it is how do we manage this transition? So if you think about fleets, typically they roll over their vehicles about 10%. So given the mandates, which are federal, state mandates, but also their corporate internal sustainability mandates, if they are to roll over a fleet in the next 10 years, they have to start now because they do a 10% rollover. And so they need a transition plan to help them make that transition. And these are all business critical, mission critical fleets, and they cannot afford any downtime in terms of, they don't have time to manage this transition and hold off on their operations. So the operations have to move hand in hand as these fleets scale. They also are struggling with how do they manage energy costs, so demand charges, time of use charges, because as we all know, electricity rates vary depending on time of use, depending on how much you use, when you use, where you use. And these are all this is the essence of all the complexity that our customers are facing right now. Is they see the benefits of the transition, but they are also very fearful of the complexities of this transition. Next slide, please. And this is where, as Ford Pro, we are bringing in a holistic solution in terms of not just providing vehicles, which is the starting point, but also looking at how do we build the end-to-end solution. So, for instance, we provide consultancy right at the beginning of our customers' electrification journey. We've got relationships with all of the major utilities, so we work with our customers and the utility partners to make sure that they have the right planning in place. Sometimes these utility upgrades or transitions take months before the vehicles show up, so that they have the right chargers, the right transformers in the right depots when these vehicles show up. But we also provide the hardware, so we provide our charging stations and also software. So as Chris mentioned, we provide software services that can integrate into the fleet's operations. So we know when the vehicles are coming in, what time do they leave, how much dwell time do they have, how much energy is needed. And then we look at the grid side of the equation. So what's the best time to charge? What's the best cost to charge? And help orchestrate all of that behind the scenes. This is one way that we are helping our customers manage that transition. Next slide, please. And I'll end with a few thoughts, and again, echoing these as not just Ford Pro thoughts, but I think the help that the industry needs across the board. So the first one is really being a partner in making that transition seamless for our customers, and looking at holistic vehicle-to-grid solutions. So as Chris mentioned, it's a complex layer of solutions, which usually starts off with V1G, which is really managing the load, but over time evolving that into more complex solutions that can really deliver the full benefit. So for example, we have the F-150 Lightning, and it already ships with bi-directional capabilities. Right now, we are enabling that to power the customer's home, in the sense that the battery in your Lightning can power your home in the time of emergency. But you can imagine that same platform and same technology can be deployed for fleets to scale for different purposes. So that's the first one. The second is what we are really in need of is focused regulatory and technical policies that look at all of these technologies. So V2G is one, but there's many other V2X technologies. So vehicle to building, vehicle to home, and tying that with demand response. So all of these can work in conjunction with each other and really help the grid manage the impact. So these vehicles are coming at a faster scale than the grid can manage today. However, if we work together as industry and government policies, we believe that there is a way to manage the scale and manage the impact on the grid while we are making this transition. And the last point I'd like to make is there's been a lot of focus on incentives and value streams that are tied to consumer charging, which don't translate very well to commercial and fleet customers. And so we'd love to see more incentives that are targeted for fleets. For example, our fleets operate out of depots. So the depot is a home base where vehicles go in and they park overnight. We'd love to see incentives that are focused on depot charging, for example. We also have solutions for customers that have take-home vehicles. For example, the Lightning is a great vehicle that customers take home. But again, those vehicles are charged as a business use relative to a residential use. And a lot of those incentives don't apply if it's not consumer charging. So that's one area where we'd love to get more help in terms of focus and incentives that are targeted at commercial and fleet customers. With that, I'm happy to take any questions as we get into the Q&A. And again, thank you so much for giving us the time to present today.
Thanks so much, Muffi. If there are any very quick clarifying questions from any of the members right now, we can take those either for Chris or for Muffi for the first two presentations. I'll just pause for a second for any quick clarifying questions, but then we're going to go into the more in-depth questions after all three presentations go through for the larger Q&A at the end. But I'll pause for a second here. You just feel free to just come off mute and ask the question if you have one.
Well, this is Sam Watson, North Carolina. I was trying to find the raise hand and I don't see it anywhere, so I'll just jump right in. I have just a simple question, and that is, where can we find more information on the V2G implementation for the Lightning truck? I mean, I'm curious on details like where's the smarts in the vehicle and the charger? Do you have to pair it with a specific charger? things that are all sort of, I'm sure, off screen on that beautiful picture you showed us, but are necessary parts to making this thing work. So if you can just point us to where we can go dig around and find additional information, that'd be helpful. I don't want to spend half an hour having you explain it to us now.
Yeah, and so all the information is on our website on Ford.com. To give you a quick 10-second answer, we provide the whole end-to-end solution. So the vehicle comes with bi-directional capability. We provide the inverter and the charger, and all of that is delivered as an end-to-end solution for customers who want to do bi-directional.
Okay, thank you.
Any other quick clarifying questions?
I think there's a question in the chat. What could an incentive for depot charging look like? So one of the challenges we have with a lot of incentives, for example, they are tied to public charging capabilities. So the chargers must have public charging capability to take advantage of those incentives. In a depot charging environment, that is actually not ideal because, as you can imagine, these depots are operated behind the fence for the vehicles that are just allowed inside the depot. So if we could have incentives that are targeted at operating fleets at scale. So, for example, a depot that has more than 10 vehicles not accessible to public charging and can deliver those, some specific benefits to grid impact mitigation. I think those kinds of incentives would be very helpful for depot charging. And I'm happy to take more of these, questions in detail offline. I'll put my email in the chat if folks want to reach out to me directly.
Okay, great. Thanks so much, Muffi. And if you could stick around through the next presentation, we're going to have a more in-depth Q&A after the next presentation as well. But with that, I'll turn it over to Steve Letendre, the VP of Policy and Regulatory Affairs from Nuvve, for the next presentation.
Right. Well, thank you so much. It's a pleasure to be with you this afternoon, and I'm excited to have this opportunity to share with you. In my presentation, we'll largely focus on kind of where we are in terms of the technology and what we see as some of the critical policy and regulatory challenges to take advantage of this opportunity that we're talking about this afternoon. So with that, next slide, please. So just real quickly, a little bit about Nuvve Corporation. We are a small technology company. Our headquarters is based in San Diego, California, although we do have smaller offices in different regions, including in Europe, where we've been operating for a number of years. We are a V2G technology company. We're squarely focused on developing and bringing this technology to the market. We've been operating vehicle-to-grid programs in Europe for a number of years. In Denmark specifically, we've been aggregating a fleet of Nissan Leafs and minivans and been participating in the wholesale markets. They are providing regulation services in Denmark. They have a particular regulatory environment which facilitates the aggregation of these resources to participate in those markets. Here in the United States, and I'll talk a little bit more about this later in my presentation, is we're focused on bringing vehicle-to-grid technology to the electric school bus market. So with that, next slide, please. So I think Chris did, a great job with his introduction on this issue. I just always like to kind of set the stage. As we know, the grid is in the grid across multiple regions in the country is in the midst of a major transformation, moving from traditional dispatchable resources to non-dispatchable intermittent resources. And the National Renewable Energy Laboratory has estimated that a renewable grid is going to require a tremendous amount of energy storage. In this study, I think they predicted 6 terawatt hours would be necessary nationally. Then when you move to the other side of the slide, we see where are all the lithium-ion batteries going. That's that projections of where the batteries that are being manufactured, where they're going to end up. And 90% of the lithium-ion batteries that we project to be manufactured are going to find their way into electric vehicles. So again, this is what Chris mentioned early in his presentation around electric vehicles will have this tremendous capacity for energy storage, And we know that the grid is going to require more and more energy storage as we transition and decarbonize our electric grids. Next slide, please. And again, this is reiterating what Chris and Muffi have talked about, the fundamentals of managed charging, good rate design, time of use rates, which encourage off-peak charging. And then we move to more active demand management with V1G, where you could actually provide grid services as a demand response resource. But I often argue that if you have good rate design and good managed charging programs, that EV load should by and large not be appearing during those times when demand response would be called during those peak periods. So on the far right, then we have the more, as Chris noted, the more complex interactive model where you're actually discharging stored energy in the batteries back to the grid, back to buildings. And this does create a number of important opportunities, providing value to the grid. And then that value finds its way to the EV owner and the fleet owners, which we believe is an important part of lowering that overall cost of ownership for EVs. Next slide, please. So just to get a little bit specific in terms of our approach, we have a platform and we deploy V2G systems. And I'll get into specifically what we're doing here in the United States. But we are an aggregation platform. We take individual EVs, which on their own have perhaps a relatively small amount of storage capability and capacity, but we aggregate those individual EVs and present them to the grid as a single grid resource, and what's used in the industry, this concept of a virtual power plant. So we're talking about, first of all, managing the charging and delivering the energy at the lowest cost possible, and making sure that the vehicles have the appropriate level of charge so that they can meet their primary function, which is transportation. But as we know, vehicles are idle oftentimes 90% of the time, and we can opportunistically aggregate that resource, control it and manage it, and present it to the grid as a valuable flexibility resource. And in doing so, receive compensation for the services that we provide, and then share that compensation with the vehicle owners and the fleet owners, and thereby reducing the overall cost of ownership of those EVs. And we believe that's an important driver to accelerate EV adoption and transportation electrification more generally. Next slide, please. So I'm here to let folks know that vehicle-to-grid technology, and we've heard from our colleague at Ford Pro, the vehicle-to-grid technology is here today. We are deploying systems in various geographies across the United States. And as I mentioned earlier, we have been operating vehicle-to-grid systems in Europe for over 5 or 6 years. But getting a little into the details here, vehicle-to-grid today, which is commercially available today, is based on a DC architecture. And what this means is that the inverter is located in the charging station. You draw DC power off of the school bus or an EV that's bidirectional. You convert that to AC power, and then that power is fed into the local distribution system. Now, V2G AC is certainly underdeveloped, but it's not today commercially available. And that's a situation where the inverter is based on the EV, taking DC power from the battery, converting it to AC, and then sending that AC power through a bidirectional AC charger to the grid. And that technology is under development. The standards are in the works, but I do believe it's at least 2 to 3 years from where we are today in terms of having that fully commercial. So back to the V2G DC, there are some advantages and disadvantages. One of the advantages is that it's fairly straight in terms of its interconnection process. We have interconnected our bidirectional charging stations in a number of jurisdictions. Our charging stations have been approved for interconnection under California's Rule 21, which is their interconnection procedure. And we've interconnected a number of these devices. We've also interconnected these devices in New York State, Colorado, and a few other jurisdictions. So essentially, the V2G DC looks very similar in terms of interconnection relative to a stationary battery storage system, where the inverter, again, is based in the EVSE, or the charging station. Next slide, please. So just to kind of highlight where we see the real critical importance of bidirectional infrastructure. And so we believe that bidirectional infrastructure is something that we need to prioritize and incentivize. And there are a number of, we think, to be very important benefits of pursuing that development of that bidirectional infrastructure. As I've already mentioned, if you have this bidirectional infrastructure, you can participate providing grid services, and that money, that revenue can be, again, brought down to the EV owners and the fleet owners, and then thereby reducing the overall cost of ownership. Also, as mentioned, as we know, we're going to have more and more intermittent resources connecting to our network, and that intermittent resources are going to require greater grid flexibility, and EVs will represent a very important and very large flexibility resource on the system. I think the third bullet here, one benefit of vehicle to grid that sometimes is overlooked is that we have to invest significant amount of money in stationary storage. And if we can allow vehicles to provide double duty transportation and providing storage services to the system, that's going to reduce the investment that we'll have to make in stationary storage projects. And we think there's some important benefits in terms of material and resource efficiency. And we also think that there is some benefit in terms of a hedge against the ability to deploy stationary storages in a fashion and a scale that is commensurate with the need on the system. And then obviously, we believe that grid flexibility will become increasingly important. We've actually been participating in California with electric school bus installation, San Diego Gas and Electric Service Territory, where we've been participating as a reliability resource through their emergency load reduction program. So we believe that electric vehicles can play an important role in mitigating these, what we're seeing, more frequent extreme weather events, which are driving electric grids and creating significant reliability challenges. So even before we have a power outage, we think that EVs will play a critical role in avoiding those power outages that are driven by these extreme weather events like we saw in California. In September, we had that significant prolonged extreme heat event. And we were one of the resources that was participating that helped avoid rolling brownouts in that region. And then finally, there's a real important resiliency benefit. And obviously, Ford Motor Company saw customers really having an interest in having the ability to use the electric vehicle as a form of backup power for their home. And we believe that that bidirectional infrastructure is going to provide some really important resiliency benefits for communities, for homeowners. And we think that that's another critical consideration as we think about programs and efforts to incentivize investments in bidirectional infrastructure.
Okay, Mr.
Next slide, please. I've just got a couple more slides and then we'll open up for questions. So I wanted to just tell you a little bit more specifically about our commercial V2G offering. We have a 60 kilowatt bidirectional DC fast charger. This is a product that's produced by a Michigan-based company, Rhombus Energy Solutions, formerly Rhombus Energy Solutions, now Borg Warner. And we white label that, and we integrate our technology into the charging station. And then we've been working with a number of OEM bus manufacturers, with Bluebird and Lion Electric specifically, and we integrate our technology and do what we call kind of a custom integration, where we now have a charging station bidirectional and a school bus that's bidirectional capable, and we can deploy these systems, first meeting the school district's transportation electrification goals, while also providing this additional bidirectional capability, providing value to the grid and value to the customers. And I should note that our charging station is fully UL 1741 SA certified. So it's, as I noted, approved for interconnection in California and other jurisdictions as well. And we are also working with a number of other OEM manufacturers to expand our offering. But today we're in this situation where there's this custom integration, we're moving towards interoperability, but again, V2G technology is available today and we're deploying it at scale. Next slide, please. Just to give you a sense of some of our installations, we've got most of our installations are focused in California. By the end of second quarter of this year, we will have well over 1 megawatt of V2G resources available in California, and we will be preparing those resources to participate again in the Emergency Load Response Summer 2023 program, which will be starting in May. And so we'll be again creating value for the grid and being compensated for the services that we provide. We've recently completed a project in
good boy.
in Suffolk, New York State, in Long Island.
Good boy, Bailey. Good boy.
I think Norm.
Sorry, yeah, just a reminder for everybody to mute your phones if you're not speaking.
And so New York State, thank you. New York State has a program, an opportunity for compensation for exports to through the distribution system. It's called the Value of Distributed Energy Resources, their VDER program. And so we're preparing that project to participate and be compensated to that program. Next slide. So this is my last slide. I just want to obviously, the work that you all do is critically important. I've said this, this decarbonization, transportation, electrification is really a critical issue that the commissions are working on across the country. And it's important, challenging, and complicated work. But I just want to offer to you a sense of, from our perspective as a VTG technology company, what we see as the priorities. First, we'd like to see incentives for V2G deployments. So an incremental incentive to encourage school districts or fleet owners to make that extra incremental investment to have that bidirectional capability. Then once you have that bidirectional capability, there has to be programs and offerings which compensate for those V2G exports. And we're seeing more and more opportunities across the country where utilities are recognizing the value of that resource and putting in place programs and mechanisms that compensate for those services. Interconnection, that's not an issue that's unique to V2G. That's an issue that is a challenge for many sorts of different DER technologies. But there is a need to kind of streamline that process and make that more efficient and less time delays and less costly. We're starting to see some jurisdictions look at V2G in the IRP process, the Integrated Resource Planning process. The state of California, for the first time, their IRP, system-wide IRP, is looking at V2G technology and trying to evaluate V2G, its impacts and its costs relative to other traditional resources. We think there's a real important need to begin to really think about V2G as a resource alongside other types of resources that can be deployed to meet the demand for electricity. Future proofing, I think I've mentioned that. Every unidirectional charger that's sold and installed is a lost opportunity to take advantage of the benefits of V2G and bidirectional capability. And then there is significant work that still needs to be done around technical standards, particularly around the V2G AC. This is more challenging with the inverter that's located on the vehicle that would be moving potentially to different locations. So there are standards that are underdeveloped by the Society for Automotive Engineers and IEEE. And so there is certainly more work that's needed there. And there is also work in terms of moving towards these interoperability standards and communication protocols that will allow for that longer term gigawatt scale opportunity that we all see as a potential when we achieve that 30 million EVs on the roads by 2030. So with that, that concludes my comments. I have a slide here for folks if they'd like to have my email address. I'd be happy to answer questions offline, but I also look forward to the remaining time we have to answer any questions that you have. So thank you.
Fantastic. Thanks so much, Dave. That was a great presentation from all three presenters today. I definitely have some questions that have come up, but I want to offer the opportunity for any of the other commissioners or commission staff who's on the line today to ask any questions first. But if we don't get anybody immediately, I can jump in. So if anyone has questions, please do just hit reactions and then hit raise your hand. Eric, I see you. You can kick us off.
Yes, thank you. I have a question about the savings for this other technology, future technology of the V2G to AC. I think if I understand that correctly, that by saving infrastructure costs, that means that but it's done on board. That means there's an inverter on the bus itself. And I wonder if that could prove more expensive in the sense that it would make the bus more expensive and that might cancel out the savings of the infrastructure.
Yeah, no, thank you. That's a great question. The so it's understood, and it's not necessarily quantitative analysis that has supported that, but it's generally understood that there's the potential for V2G AC to be less expensive by having the inverters on the EVs. You have the incremental cost of having that inverter on a bus or an electric vehicle, a general electric vehicle. There's a lot of the existing power electronics already embedded in the vehicle. And so there is an incremental cost of allowing that bi-directional capability. And that avoids, excuse me, having to purchase a more expensive DC fast charging unit. So I think the savings of having a lower cost bi-directional AC unit is greater than the incremental cost of having that bi-directional capability with the inverter on board the electric vehicle. So that's kind of the conjecture, is that there is this likely potential cost savings of moving towards that model where that inverter is based on the electric vehicle.
Thank you.
Interesting. Yeah, Eric, I actually had the same question and wanted to expand on that a little bit too. Not only should you consider the difference in cost that would go with the moving the inverter to the bus or the electric vehicle, but I think, if I'm understanding right, you would essentially be driving that inverter around everywhere with you instead of leaving it stationary. So I wonder if there's not only extra cost that goes around with that, but extra weight or extra expense of moving that inverter every mile with that vehicle as well, and if that's been considered.
Yeah, I would say, again, most of the components are already on an electric vehicle, and there is some, additional incremental investment, some hardware and software that would allow that bi-directional capability and being able to draw AC power off the vehicle and feed that through a bi-directional AC charging station. So I don't think there's going to be significant incremental weight, or there would be some incremental cost associated with that. Really, I think the biggest challenge is the getting the utility comfortable with having inverters that are mobile, moving from one location to another location. Interconnection today is based on, a discrete DER that is at one location. It's got a stationary inverter, and it meets, the UL certifications. So I think, that's where these standards and protocols really are going to be critical to make sure that we have this safety and assurance that these mobile inverters will operate safely with a variety of different charging stations. So I think the biggest challenge there is making sure that we have the standards and we get the utilities comfortable with this concept of these inverters that would be moving from location to location.
Yeah, and maybe I can share a little bit of perspective. It also depends on the vehicle class as well. So to give you a very specific example, with the F-150 Lightning, we have two options. We have the standard, 11 kilowatt, and then we have a 19 kilowatt dual onboard charger for the extended range. And those are options based on what the customer chooses. Of course, it adds to the cost of the vehicle. But Katherine, to your point, there's also the cost of carrying that weight around, which in turn has a direct impact on the vehicle's range, towing capability, payload, etc. So yeah, I mean, we look at all of these trade-offs, and the less weight on the vehicle obviously is better. But at the same time, there is this balance of, how much dwell time the vehicle has and how much time it'll need to charge back up.
That's really helpful. Thank you both. Joey, do you want to go next?
My question is a little bit related to the last point. When you're looking at electric vehicles as potential grid resources, I think that's a great way to unlock the value. But I've always wondered about, I've always had this nagging question. Does it necessarily come at the expense of the vehicle's utility? You know, so vehicles need to be driven. And so if you're now going to be piloting, in my mind, kind of piloting their potential as a grid resource, how they're going to feed into the grid, and especially if you're going to do it in a way where they do this in response to like an emergency situation. Well, doesn't that necessarily mean you're going to draw down on the capacity of the battery? And so then all of a sudden the school bus can't leave at 3 p.m. to go pick up children. Have you found that it necessarily means this zero-sum type of relationship, or as it is there a way to manage that effectively?
Yeah, so maybe I can take that one. Joey, your concern is 100% valid. This is what we hear from our customers, especially that the ones that operate these mission critical fleets. If it's, if it's school buses, or if it's delivery vehicles or first responders, their number one objective is to make sure that the vehicle is charged and ready when they need it. Everything else becomes secondary in terms of getting any other sort of economic benefit. And this is also a sort of an artifact of how these organizations are structured. So for example, we work very closely with fleet managers, and their objective is to make sure the fleet is up and running. They are not incentivized to make money off of operating the vehicle or energy. The facilities guy who operates the energy infrastructure has some incentives to reduce energy costs. So I think the right way to think about this is to see the holistic solution. And I'll give you an example. So we work very closely with utilities. And one of the benefits they see in working with an OEM like Ford is that we can give them insights into how existing fleets are operating. So for example, we have internal combustion vehicles that operate at scale, and we can use a lot of the operational data. So what's the vehicle miles traveled per day, how much time does the vehicle have to dwell before it can get charged up. And so we can use all of the data to help plan how these operations are going to work. And not only managing it from a scale standpoint, but also from a location standpoint. So we know exactly where these fleets are located and where on the grid this demand is going to show up in the future. So I think it's a long way of saying that this has to be a very interesting balance between making sure that the fleets operate at scale without disruptions of their operations while we manage the energy equation on the other side.
Yeah, I would certainly agree with that. And it really, every fleet I don't think is going to be a great use case for vehicle to grid technology. One of the reasons we focused on the electric school bus market is we do have these long periods where the electric school bus is sitting idle during the summer months during their vacation, which is exactly the time when many grids are experiencing those peak strains and where these resources are most valuable. But I do think there is this power of aggregation. If you're aggregating hundreds, thousands, tens of thousands of vehicles, absolutely the EV owner should have complete control to override and make sure that they are getting services that they need in terms of transportation. But there will be, I believe, significant opportunities to aggregate resources and create value for the system and for the EV owners.
And I think I'll just layer on one more thing, is that, so we talk about the customer's willingness to sacrifice some aspect of their vehicle, at the same time that we have services like Uber and Lyft, where people sacrifice their own time plus their vehicle's time plus their vehicle's degradation in the service of earning some money from offering transport. Choice. Not everyone will choose to make those services available, but as the technology is more smooth and more interoperable, we think as that barrier goes down, just like in the case of Uber, if there's an incentive to be offered, then there will be parties willing to accept that.
Thank you.
Yeah, I think that goes a bit to the question, the follow-on question that's in the chat too, about is it a worry that constant V2G usage could actually harm the vehicle's battery? That is, reduce the amount of charge the battery can hold. And I think, Chris, your response is similar to a similar answer, I think, to that. That if there's enough incentive, that someone might choose to make that trade-off for themselves, is how I would interpret that. But please feel free to build on my crude answer.
No, it's very much the same thing. As that there are customer choices at bay, and the customer has dominion over those choices. And so, if in the case of giving up their own personal time plus their vehicle's use is an indicator of willingness, then it's likely that we'll have that same type of willingness in a V2G environment. Yeah,
and I'll just add that we are seeing the OEMs beginning to bring this functionality to their vehicles, and I believe Nissan, they work closely with one of our competitors, Fermata Energy, which has a bi-directional charging station, and they've actually have explicitly stated that Nissan, will not void the warranty for the use of the V2G function that comes with their vehicles. So I think, I do think we're starting to see auto OEMs understanding that the customers could see this potential trade-off opportunity and want to enable that for them.
Fantastic, thanks. I do have one question that I want to get in before we end, but we have 3 minutes left. Drew, do you want to? You can ask yours first, and then I'll go.
Sure, thanks. I appreciate it. So in Maryland, we have a legislatively mandated EV school bus pilot that involves V2G. But so I was always just curious on the compensation for the V2G. I guess this would be a question for Steve. Like in California, what exactly does that look like? Is it similar to a demand response program kind of compensation structure, or do they have any utility tariffs for that? Or so I'm just curious. We don't have anything like that in Maryland as of right now for V2G. Yeah, no, that's happy to answer that. Yeah, so California, they have an emergency load reduction program, a demand response program. And they specifically have a segment that allows electric vehicles to participate in that program. And the compensation is $2 per kilowatt hour for injections during these events. But we are seeing migration towards dynamic rates with export compensation. So PG&E, Pacific Gas and Electric, has a dynamic rate that includes compensation for grid exports. That will be available, I think, to customers starting in Q1 of 2024. And then, as I noted, in New York State, they've got the VETR program, which provides compensation based on a value stack of the different components of value that the injections bring to the system. So there are some models out there, but yeah, it's really evolving from the DR to what I think ultimately will be these dynamic rates with compensation for exports. Great, thank you.
That's great, thanks. So the last question that I want to ask, it came from Muffi from your presentation, but I think each of the presenters might have some sort of perspective on this. Muffi, you talked about utility regulation and the different how you're thinking about that. So because all utilities are different and every state's regulatory environment is different, how do you think about navigating those complexities and that challenge? Like, is this something that you help your customers navigate, the different the regulatory environments? Like, how do you learn about the different regulatory environments? Because even as a regulator, I don't understand all of the different regulatory environments throughout the country. And what do you need from us as regulators to make your job of understanding and coordination easier?
Yeah, a great question. That's one of our in all honesty, it's one of our pain points right now. And the way we are doing this is it's almost hand-to-hand combat. Is we work directly with utilities based on a prioritized list of where our customers are getting their electric vehicles. Fortunately, we've got a relationship with most of the major utilities already, just from the fact that they're our customers already. So they're using our vehicles, ICE vehicles in many of these cases, but they're also testing out our electric vehicles as sort of piloting their own fleets with EVs. What is challenging is it's a very fragmented landscape, as you've already said. So utility incentives vary, programs vary. What would be helpful for us is if there are a few frameworks or constructs that can be provided industry-wide. So maybe 2 or 3 constructs that utilities can adopt, and so we can quickly fit our our solutions to one or more of these constructs. So right now it's just we are figuring things out as utilities themselves are evolving their strategies. And some of them are piggyback on what others are doing. So for example, PG&E, SoCal Edison, they're kind of leading the way, in terms of programs like their make-ready programs. And there are a lot of other utilities that are piggyback on, okay, this is what's happening in California, let's build something similar off of that. So we are already seeing some trends emerging, but if there's a way to accelerate and create maybe a playbooks for utilities to follow, I think that'll go a huge way for us to help our customers take advantage of all these programs.
If I could just add, I would just say I totally agree. I think that was excellent response, and really, around interconnection, around compensation, and then kind of the incentives for infrastructure investment. I think if those are kind of some topical areas where it would be nice to see some coordination and common best practices to move the industry forward.
Okay, fantastic. Well, thanks. Really appreciate your time. Really appreciate the presentations and the thoughtful answers to the questions as a part of the Q&A. So at this time, we'll have all non-members drop